All right, so let's look at another example. I'm going to call this example 4, depending on which sheet you're looking at. And this says calculate the minimum and maximum point and the zeros of a function using your graphing calculator. If necessary, round to the nearest hundredth. So we're not even going to graph this one by hand, but let's just review this process again. If I'm looking at this quadratic equation, whether I'm graphing it or trying to find the vertex or trying to find the minimum or maximum, I would always figure out what is negative b over 2a. You always go there, okay? So let's just review that process from the last couple examples. If I were to calculate this out, I would say the b value here is negative 2, right? So the b value is negative 2. If I took the opposite of b, that'd be positive 2, and divided by 2 times a. Well, a is negative 1/2. So negative 1/2. And so if I multiply this out, I would have 2 divided by negative 1. And so I have negative 2 is the x value, or I should know that it's the x value of my vertex. And then if I was going to do this by hand, I would continue plugging in that negative 2 back into the function to find what the full vertex is. And then I would plot in more points, and I would try to fill out a nice looking graph from there. Okay, but here it asks us to use a graphing calculator. So if you have a graphing calculator, I want you to take that out, and I want to show you some of the features that you can use here. If you don't have one in front of you, but you have like Desmos or something like that, you know, that would be the next best thing is just plugging it into a Desmos. But if you have the graphing calculator, you're going to go into y equals, and just as the previous chapters, you can plug in the function that we're working with. So I have negative 0.5 x squared minus 2x plus 6. And I could just go right ahead and graph it if I wanted to by hitting the graph button, and you're going to see the whole graph. If you are zoomed into a weird spot, or you're not seeing the same thing on my screen, you could go and change the window of your graph, or a shortcut to that is clicking on zoom, and if you go to number 6, it'll always go back to a 10 by 10 standard graph. So sometimes just hitting zoom 6 is the easiest thing to do, because that'll put you to a 10 by 10 graph, and then you can change it from there as necessary. But what we want to do here is figure out the vertexes. The vertex is up here. So we could do that in a lot of ways. First of all, we could trace this function. This is something that you should know how to do. If you click on trace and you just use your left and right buttons, you can just basically go around this curve and just trace it, and you can see your x and y values right there. We certainly could approximate the vertex, right? This looks like the vertex, and it looks like negative 1 or almost negative 2 that we calculated, and about 7.999 looks like it's going to be 8, right? But there is a way to get the exact vertex, and if you want to do that, you're going to go to, instead of hitting trace, I want you to hit second and then trace to go to this calc function. So second, and then you click on trace, and it's going to say, what do you want to do with this graph? And you can say, I want to find, in this case, I want to find the maximum value, because this graph has a maximum value, not a minimum. So I'm going to click on 4, and then it's going to say, okay, click somewhere to the left of the vertex. And so we just make sure that we click to the left, so we're somewhere to the left of the vertex, and click on enter. And then it says go to the right, or what is the right bound? So we click to the right until we go somewhere to the right of the vertex, and I click on OK, and then I have to click on enter one more time, and it will calculate it exactly for me. So it says the vertex is negative 2, and the y value is 8. Now you notice that it actually, on my screen, it has negative 2 point, and then it's like 0.000, and then there's a 2 here. that's just the calculator making a little bit of a rounding error there, because it's not actually doing it mathematically with an equation that we did up here. It's actually just kind of doing it like a computer would, and just getting closer and closer and closer and closer and closer to it until it approximates it so well that it's basically right at the exact answer. Just ignore that extra 0.2 there. So it's really -2, 8. So I know my vertex here is -2, 8 as verified by the calculator, and of course I could then take this and I could have plugged it into the equation and also gotten 8 from there as well. So that's how you find the vertex from a calculator. Now it asks also, what are the zeros? And we haven't talked about that yet. The zeros of the graph are going to be in other words, where is the y equal to 0? If I go back to my graph, it's asking for, where are these spots on the graph right here? You can see there's 2 of them. Where's the graph right at 0 in terms of the height? That would be 1 over here and 1 over here. If I want to find that 0, I could trace and approximate it, or again, I could go to the second. I could click on second and then click on trace to go to the calc menu. And then it's going to say, all right, you can go to the 0 function here. So I'm going to click on number 2. And then it's going to say, all right, go to the left and to the right of where your 0 is. So I'm going to do the same thing, but now I'm trying to go to this left 0 over here. So I'm going to go a little bit to the left of it. I'm trying to get this one right here. I'm going to say OK. And then I'm going to go a little bit to the right of that 0. And then click Enter. And then click Enter one more time. And then it's going to go exactly to that 0. So -6 is going to give me a y equals 0. So one of the zeros is -6. So if I went back to my problem, one of the zeros is x equals -6, right? Which means that if I plug in -6, it gives me 0. It gives me a 0 for the height or the y value. Now if I want to find the other 0, I just have to do that same exact process. So I'm going to hit second, go to trace, or second calc, and then say 0 again. And now I'm going to go to the right 0, or this other 0 over here. And it's asking for a left bound, so I'm going to go to the left of it anywhere. So I'll say right here. And then I'm going to go to the right of it, or sort of below it. And then I'll hit Enter again. And now it gives me a 0 of 2. So 2, if I plug in 2, it's going to give me 0. So that means that x is 2, or a 0 is 2. So if I plug in 2 into my function, I would get another 0. So my vertex is -2, 8, and my zeros are -6 and 2 for that problem. Now, again, if you don't have a graphing calculator, and if you were to do this on Desmos, you could do the exact as well. If I go to Desmos here, and let me get rid of some of this stuff, I could also plug in the function, which is -0.5 x squared, or y equals, I should say, minus 2x plus 6. Minus 2x plus 6. And you could look on Desmos as well, and you could see the vertex is -2, 8. And you're also able to click on the zeros, which are -6 and +2. It's very beneficial to know how to do that on your calculator, so that you know how to do that in any sort of testing environment or in the ACT or anything like that. But Desmos can certainly handle something like that as well. All right, so here's one to practice. You can go ahead and pause the video, see if you can use a graphing calculator, or if you want to practice it by hand again, to find the vertex, and then also find the zeros of the function. So go ahead and pause that. All right, so if you were to graph the function, you would get, let's see, negative 4x squared plus 12x plus or minus 9. If you graph it, you get this. And then if you found the vertex, you go to the calc, and it's a maximum here again. So I go to number 4, and I would go to the left, hit enter, go to the right, hit enter again, and enter one more time. And you can see here that the maximum or the vertex is at 1.5, comma, and then I have negative 2.6 e to the negative 11. What that means is that's in scientific notation that this calculator is using, and that's negative 2.6 times 10 to the negative 11th. And so it's a really, really, really small number. And in other words, it's like negative 0.00000, like 10 or 11 zeros there, 264. So this right here basically means y equals 0. So when you see this, don't get confused. That's just a really, really tiny number. And for some reason, it just doesn't put y equals 0 there. But so the vertex here is going to be 1.5 comma 0, as you can see on the graph. So for this practice problem, I'd say 1.5 and 0. And then the zeros, if you did that, man, it looks like because the vertex is right at 0, there's only going to be 1 0 in this problem. And that's going to be the same thing as the vertex. So the 0 should be x equals, sorry, not x equals 0, but x equals 1.5. Should be the same thing as the vertex. But we could double check that, and we could say second trace, and we could say tell me what the 0 is. And we could go to the left of it, and we could go to the right of it, hit enter, and you can see we get the same thing. About 1.5 is the 0. So we get the same thing. So notice that in this practice problem, there is not 2 zeros, there's only 1 0. And that's only going to happen, if you think about it, when the vertex happens to be the only times it hits the x-axis, or when the vertex is the 0.